Okay, folks, today we're going to take a look at how we use the data analysis tools within Excel to create a test for the sample variances and for the sample mean. This is called an F-test and a T-test respectively. So let's take a look at the file we have in front of us. We have data here about Boca and Delray. Well, the Palm Beach County school officials, they want to know if they should be concerned about the variance in the time it takes for kids to ride the bus. Basically what they're seeing is that there are some students who have to take as many as 40 minutes, while some students only take 5 minutes, and they want to make sure that all of their area is serviced well. So they have decided to take a look at the Boca and the Delray bus times to decide if there's a difference in the variance and the mean. So the first thing we want to do is develop the hypothesis to determine if the variances are different. Now this is actually easy for a variance or an F-test because there's always the same variance. There's always the same hypothesis. In a F-test for variances, there is always the same hypothesis, and it is that the variances are different against the fact that the variances are not different. Now, let me go over that one more time. What we want to do is we want to test to see if the variances are different. And what we're looking at is a statistically significant result. Now, by that I mean we want less than a 5% error rate. Okay, we want a less than 5% error rate. This means that we can be 95% confident in our answer. And so, at this rate, we have a very small margin of error. We're not looking at anything substantial. We just want to find out if there is a statistically significant difference at the 95% error rate. To conduct our t-test, we'll simply follow the steps that are outlined here. Click the Data tab on the ribbon, go to Data Analysis, conduct an F-test to sample for variances. F-test to sample for variances. Click OK. Variable 1 range is going to be Boca Raton. Variable 2 range will be Delray Beach. Because we selected the first row, we want to make sure that we check the box that says Labels. We want to be 95% confident in our answer. So alpha, the error rate, is going to be 0.05. Our output range will be D15, so that we end up putting it right here in the blank space. We click OK, and these are the results we get. I'll go ahead and make those larger for you so that you can see them on the screen. In addition to that, I want to round everything to the nearest 2 decimal places. So I'll go up and I'll click the comma. Now let's interpret our output. The first thing we see is that the mean or average is relatively the same. There's not much difference in the variance, not much different in the mean or average between Boca and Delray. But we can clearly see that there is a difference in the mean. What we don't know is that difference a statistically significant difference? We look for the p-value to determine that. And the rule is if p is less than or equal to alpha, we reject the null hypothesis. All right? Again, if p is less than or equal to alpha, we reject the null hypothesis. This is one that you need to really hone in on because we're going to use the p-value approach throughout the rest of this video. So if the p-value here, 0.04, is less than alpha, our error rate, then we reject the null. Because 0.04 is less than 0.05, we are able to reject the null hypothesis, and we conclude then that the variances are indeed different, right? So we reject the null hypothesis and conclude that the variances are different. So to answer question 3, can we reject the null hypothesis? The answer is yes, because the p-value is less than alpha, which is 0.05. Okay? And because we can reject that null hypothesis, we can conclude that the variances are, are different. All right? So this is our answer to this. And here we conclude that the variances are indeed different. So now that we know that the variances are different, we know what kind of t-test that we can use to determine if the means are different. Now we already know they're not. We can look here and determine that that's probably not going to be the case. But we still want to go through the practice of making sure that we understand this. So because the variances are different, we're going to go to Data, Data Analysis, and we scroll down until we find t-test assuming unequal variance. Okay, again, the variances are different, therefore they're unequal. Variable 1 range will be Boca Raton. Variable 2 range, Delray. My hypothesized mean difference is 0 because these are close together. So we're going to put in a 0 there. Check the box that says labels. Again, we want to be 95% confident. So alpha is 0.05. My output range for this will be here in F38. We click OK, and here are the results that we get. Again, we round them to 2 decimals, and I'll increase the size so you can see it. Here, because the means are different, we look at the two-tailed test. Clearly, 0.99 is much higher than 0.05, right? So again, we say if p is less than alpha, we reject the null hypothesis. But p is not less than alpha, therefore we cannot reject the null, and instead we reject the alternative hypothesis, and we conclude, right? So the conclusion here is going to be different. We ask, could we reject the null hypothesis? The answer is no, right? So because we cannot reject the null hypothesis, we have insufficient evidence to show a statistically significant difference. Okay? Because we cannot reject the null hypothesis, we have insufficient evidence to show a statistically significant difference between the means. Now, I want to point out that this does not mean that we have proven that these two are equal. Clearly, they are not equal. What it shows is that they are not statistically significant differences. Let me go through the semantics of what we're saying here, okay? When we look at the means between Boca Raton and Delray Beach, we're looking at 1/100th of a minute, okay? So the difference between these two is 1/100th of a minute. So equals 1/100 times 60 that means that we have about 0.6 seconds difference between the two. Is there a difference? Yes. But that 0.6 of a second does not make that much of a difference. Okay? So that's what we mean when we say that there's no statistically significant difference between the two. All right? Now, with that in mind, let's go over and take a look and do another problem on the battery time. Okay? So here, we're looking at the difference between the battery time on your smartphone. So we know that smartphones here, in previous research, we have surmised that the average is 20 hours when talking and 7 hours when you're on the internet. Now that's generally because all you have to do is carry voice here, but on the internet you're having to carry pictures, you're having to carry other things, right? Okay. What we want to find out is there a difference between the variances and the mean for this particular set of data? So again, our variance hypothesis is always going to be the same, right? Variances are different versus variances are not different, okay? Notice that I did not say variances are the same. That is not what we're trying to show. Okay, so we're going to do our test again. We'll go to Data, Analysis, F-Test, click OK. For range 1, we're going to go to talk time. Range 2, we're going to go to internet. So we have A1 through A25 and B1 through B25. Again, we want to be 95% confident, so alpha is going to be 0.05. My output range for this one is going to be in D19 this time. We click OK. Here are our results. I will round this to 2 decimal places and make it a little larger so you can see it. Okay. So now we can see that we have the variance here is much different, right? As a matter of fact, we have a p-value here much less than alpha. And remember, if p less than or equal to alpha, in this case 0.05, we reject the null. Okay? If alpha is less than 0.05, we reject the null. All right? And we spell reject correctly as well. Okay? All right. So, because this is 0.00, which is clearly less than 0.05, we reject the null hypothesis, and we conclude then that the variances are different. Right? So again, on question 3, can you reject the null hypothesis? Yes, because p less than or equal to alpha. And in this case, 0.05. Keep hitting that O. Okay. What conclusion can we draw from this test? The variances are different. Right? In fact, we can say that there is a statistically significant statistically significant difference in variances. So now we're going to again do the right t-test. We'll go Data, Analysis, t-test assuming unequal variance. One more time. Data, Data Analysis, t-test assuming unequal variances. Variable 1 range is A1 through A25, which is the talk time. Variable 2 range, B1 through B21, which is the internet time. Hypothesized mean difference is 0. We are always going to put 0 here. Check the box that says labels in the first row. Output range for this Again, we will put it down below in H42. Click OK. Here's the differences that you get when you look at the p-value for the two-sample test or the two-tailed test. And that's if you have a variance that's different, this is always going to be that two-tailed test. And we're going to keep it simple, and we're going to call it different rather than greater than or less than. So we look at the two-tailed test, and we conclude that because the p-value is less than alpha, we can reject the null hypothesis. This p-value is clearly less than alpha, and so we can reject the null and conclude that the means are different as well. Right? So we reject the null and conclude that the means are different. All right? Okay. So now we know that the variances are different, and we know that the means are different. We double check our data, and clearly we can see that. Right? Clearly we can see that the talk time mean is greater than the internet time mean. So we can then say not only are the variances different here, but we can also say that the means are different. So we have statistically significant evidence to show that the talk time battery life is greater than the internet battery life. All right? Let me jot that down for you here. Okay? We have statistically significant evidence shows that the means and variances between talk time and internet time are different. Okay? So, that's our conclusion. We have statistically significant evidence to show that the means and variances are different. Let's do one more, and then we'll call it a day. All right? So, the Air Force is going to use a personalized training system to try to train its avionics techs. And so the avionics techs are the ones who make sure that the radar systems and guidance systems on all of their planes are actually working correctly. All right, so let me blow that up a little bit so you can see it on the screen a little better. So we want to develop our hypotheses to determine, or hypothesis rather, to determine if the variances are different. And once again, it's always going to be the same, right? Okay. Variances are different versus the null hypothesis that the variances are not different. Okay. Same F-test as before. Data, data analysis, F-test, two-sample for variances. Click OK. Variable 1 range will be the video time. Now, there are over 100 different data points here. So I'm simply going to do Control-Shift or Command-Shift, down arrow, and I'm going to select all 62 of them. There's only 62, so that's not too bad. For computer, it's again Control if you're on a PC or Command if you're on a Mac. Command-Shift, down arrow to select variable 2 range. Alpha is going to be 0.05, output range again in D19. Okay. Click OK. Here's the output you get. I'll round it to 2 decimals and increase it to 16-point font to make it easier for you to see. P-value is less than alpha, so we reject the null because if P less than or equal to alpha, we reject. Okay? And we know that alpha is going to be 0.05 because we want to be 95% confident. remember that alpha equals 1 minus your confidence interval or confidence level. So in this case, alpha equals 1 minus 0.95, which equals 0.05. All right, so, okay. So we're going to reject our null hypothesis. We conclude then that the means are statistically significant different. Can we reject the null? Yes, because p-value is less than alpha, right? Okay. What conclusion can we draw? The variances are different. Okay. Let's use that now to test if the means are different. So we're going to data analysis, t-test assuming unequal variance. Click OK, and put one range video, input two range here. Hypothesize the mean difference is 0, alpha is 0.05. Output will be here in H43, and we click OK. Go back to the Home tab, click the comma to round it to 2 decimals, and I'm going to increase that to 16-point font so you can see it a little better on the screen. Here we look at the p-value of the two-tailed test because it says different rather than less than or equal to, and we cannot reject, right? The rule is, again, if the p-value less than or equal to alpha, we reject the null hypothesis. P-value is not less than 0.05. 55% is not less than 5%. So in this case, we have a 55% chance of making an error. As a result of that, we have to conclude then that the means are not different. We're going to fail to reject the null hypothesis, and we conclude instead that the means are not different. Okay? Now, when we take a look at the video versus the computer, we can see that, right? So this is the number of minutes that it takes them to actually complete the task after they've watched a video versus after they've watched the computer. So if we take the difference between these two, I'm going to take the new method, the computer, minus the old method, and I'm going to divide it by the old method, right? When we click OK, we can see that there is only about a 0.5% difference between the two. While the variances are certainly different, the means are not. Now, believe it or not, this is actually good news, because what we have shown is that the variance for the computer is much less. When we're using computer-based training rather than just watching videos, we can see that the variances to complete the task go down. And this is a good thing when you're training people on how to do your process. So you want the variance to be much less, but the mean shouldn't be different here. It shouldn't be such that the computer trains them so well that one group is better than the other. It just simply means that you are taking it easier. What would happen if you had a statistically significant difference here would be that one group would be so far outpacing the other group that they would either have not enough work to do or they would have too much work to do. And so you don't want that, but you do want them to be closer around the mean. And so that's what we have had here. So I hope you enjoy this. This is going to be how you do your case study number 3. Go ahead and take a look at that. And if you have any questions, you know where I am.